Very good morning and welcome back to the another live session of CIET and NCERT. I am Shilpa. Topic of discussion of this session is acids, bases and salts, particularly for class 10. In your previous classes, you have already understood what are acids, what are bases. Acids are sour in taste. They change color of the blue litmus to red, whereas the bases are bitter and change the color of the red litmus to blue. With us, we have Dr. Anand Arya from RIE NCERT Ajmer. I welcome you, Dr. Anand.
Namaskar, madam.
Before we proceed, I would like to inform our viewers, if you come across any questions or any doubts related to our today's topic of discussion, then you can contact on our toll-free numbers. Numbers are 1800 and 1800112199. You can also send your question on our official email ID ciet.kishormanch@gmail.com. Moreover, you can comment your question related to this topic during our YouTube live streaming, which is happening now, and our official YouTube channel is NCERT Official. Dr. Arya, today we are discussing acids, bases, and salts. Yeah. There we have a concept of indicators.
Yeah.
There are many indicators to identify acids and bases. Can you tell us a bit about it? How to identify acids and bases?
Yeah, first we'll try to understand what we will cover the concepts related to acid, base and salts in today's sessions. So today we will try to understand the chemical properties of acids and bases. We will also know how acids and bases reacts with metals, and how these acids reacts with what happens when acid reacts with metal carbonate and metal hydrogen carbonates, and what will be the interesting reaction when we will react the acids with the bases, and how the acids are how we compare the acidic strengths of the acids. So in your previous classes, you have studied the general characteristics of acids, bases and salts. When it comes to acids and bases, most of the people say that they are sour in taste and they change the color of the litmus paper. So there are many indicators are there, and indicators they are basically of two types. They may be the natural indicators, or they may be the man-made or synthetic indicators. So as you have asked, there are many types of indicators. You can prepare them in your home also, and you can collect it from your surroundings. And there are some synthetic indicators. You can use them for the testing of the acids and bases in your lab. So let's play a demonstration video of the natural and synthetic indicators that will give you an idea about what are the different types of indicators and how they how you can identify the acids and bases on the basis of these indicators. So play the video, that is the natural and synthetic indicators. This video is the demonstration video which will show you how the natural and the synthetic indicators will show the different colors when they are treated with the acids and bases. So play video 1, that is natural and synthetic indicators. मुझे लग रहा है कुछ टाइम लग रहा है.
No, it's already playing, Doctor.
these are the natural indicators. Along with the natural indicators, you can use the synthetic indicators also, like phenolphthalein and methyl orange. As you have seen in the demonstration video, that is, phenolphthalein gives pink color with the basic solutions. When the bases are treated with phenolphthalein, they gives the pink color, while the phenolphthalein is colorless when it is treated with acids. Similarly, if we use the methyl orange is acidic indicator that gives a red color in the presence of acids and shows the yellow color when it is treated with the bases. So these are the two indicators. These are two synthetic indicators you can easily test in your laboratory. So let us do understand some more chemical properties of acids and bases. Have you ever wondered?
Dr. Anand, before you hop on to the chemical properties here, I would like to ask one question. Most of the time we do use litmus solution.
Yeah.
And even children do ask about litmus solution, whether it is synthetic indicator or it's a natural indicator.
Actually, litmus is derived from the lichens, that is the thallophytic plants. So it is the extract of that particular dye. So when we used to have the litmus paper, that litmus paper is nothing but that litmus paper dried over the strips of the paper. So either you can use the litmus paper or the litmus solution. Both these are the indicators that is for the acids and bases.
Okay.
Yeah.
So now you can explain us the chemical properties?
Yeah. Can you think how the metal reacts with acids? So metal reacts with acids and they displace hydrogen from the acids and they form salt. So this is the reaction, that is the metals reacts with acids and they form the salt and the hydrogen gas. So can we play the second video, that is the reaction of acids with metal? That is the demonstration video, and that will give you the picture how the metal reacts with acids and how this hydrogen gas is formed, and try to visualize it, how we can test the hydrogen gas that is produced while the reaction of the acids with the metals. So play video number 2, that is reaction of acids with metals. So for this experiment, what we have to do, we have taken the 2 test tubes. In one test tube, we will add some zinc granules, and in another test tube, we will take soap solution. Now we'll start our reaction. So put near about 2 to 3 ml of dilute hydrochloric acid into the metal zinc granules, and observe this reaction. So you can see when the acid reacts with metal, some gas is produced. So through delivery tube, we will transfer this gas to soap solution. So when this gas is passed through the soap solution, this this gas is trapped inside the soap bubbles. So you can see easily when the metal reacts with acid, it liberates hydrogen gas. And when this hydrogen gas is passed through the soap solution, we are getting the hydrogen gas in form of soap bubbles. So can we test the liberated hydrogen gas? Hydrogen is an inflammable gas. It burns with a pop sound. So when the candle is taken near the bubbles, the hydrogen gas burns with a blue flame, producing pop sound. So you have seen this interesting reaction. In this reaction, what we have done, we have passed the hydrogen gas through the soap solution. And the soap solutions will give you the opportunity for the students to observe the liberation of the hydrogen gas. So they can easily visualize that some gases is being removed, is evolved, and you can test easily. So for safety purpose, if you will pass this hydrogen gas through the soap solutions, so if you will bring the candle that is near the hydrogen gas, soap bubbles that is containing hydrogen, that will burn very easily and with the pop sound. So here, look at the reaction. So in this reaction, what we have shown, this is the zinc metal. This zinc metal reacts with hydrochloric acid, and it is forming zinc chloride. So this is a chemical reaction. In the left hand side, these are the reactants, and in the right hand side, these are your products. So here the zinc, that is zinc is the solid, it reacts with the hydrochloric acid. The formula of the hydrochloric acid is the HCl, and it forms the hydrogen. So this hydrogen gas will be liberated and it will be evolved, and it will left behind the zinc chloride. This zinc chloride is the salt. So this is how the acid reacts with the metals.
Dr. Arya, here I would like to ask two things. Yeah. One is, you talked about the soap solution. There are the two aspects you talked about. It's safe, and the second is a student could be able to see it properly. The hydrogen gas is oozing out. Is this the only reason that we are using soap solution?
Generally, what happens when we perform this experiment, that is the reaction of the metals with the acids, the hydrogen gas is evolved. So this hydrogen gas is a colorless gas, so students cannot easily see that some gases, even it is odorless also, and it is not good to inhale hydrogen also. So the soap solutions gives you the better understanding that some gas is being evolved. So it gives you the opportunity to visualize that hydrogen gas, some gas is evolved, and this gas is hydrogen. So now, once they will visualize that the gas evolved as hydrogen, then they can test it easily. So the second thing is, whenever you will perform such experiment in classroom, what will happen? This hydrogen is highly inflammable gas. So when the candle or any burning source that comes near to the hydrogen, it burns very sharply. So if we want to show this particular reaction in our classroom situations, then such procedures will make the students to easily visualize, as well as it will make the method safer, so that it can be shown in the class of to all students. So you can control the burning of the hydrogen gas. So like we have seen it, it will burn with the pop sound, but the intensity of the burning of the hydrogen will not be so, and it will be burned in a proper, like without bubbles.
Okay. And one observation-based question, Dr. Arya. Most of the time, we are asked not to put curd or sour substance in brass or, let's say, copper vessels. So is it something related to the generic reaction you have mentioned here in the PowerPoint, like metal plus acid gives the salt plus
Obviously,
hydrogen?
when we have the metals like copper, so curd is the basic substance that contains the so lactic acid and something.
Mm-hmm.
So that particularly reacts with the copper, and that forms the salt. And these salts are not good for health. So that's why we used to. It is a precaution that one should not keep the acidic or basic foodstuffs in the metal containers.
Right. So, Dr. Arya, most of the children are commenting that why we actually read this chapter. So, I guess they have got the idea that why we need to study this chapter. If you could
Yeah,
just explain more. Yeah.
acids and bases are part of our life. They are always with us. Everything, whatever you are observing, either it is in the kitchen or it is outside, everywhere you will find the acid and bases. So it's very important to understand the basic chemistry and what is the basic chemical properties, how these acids and bases react. So that is why this chapter is one of the most important. And the students found it very interesting also to read it and to perform the experiments related to this one.
Right.
Now you are at the home, so you can perform these experiments at your home also. Like if you don't have the acid like hydrochloric acid or sulfuric acid, nitric acid at your home, then you can use the other sources of the acid at your home. It could be vinegar, it could be the lemon juice, it could be a number of things that they are present in normal in the house. And in place of the bases, like you can use the soap solution, even your baking powder, they are also the base form of the bases. They are easily available in at our home.
But still, Dr. Arya, they have to take precautions and they have to take the guidance of adults, right?
Definitely, they have to take the proper precautions while performing. Every time, whenever you are performing experiments, safety should be the major concern. You must be very safe while performing all these experiments.
Right. Yeah. So what will be the next thing we are going to learn?
So what will happen when we'll perform the reaction of the bases with metals? So okay. Base also reacts with the metals in the similar manner. They also displace the hydrogen, and along with the hydrogen, they forms the salt. But the intensity of the base, that is the liberation of the hydrogen, will not be as it will be in the acids. So here they will form the salt and hydrogen, and this salt is like here we have shown, that is here, that is when the zinc is reacted with sodium hydrochloride. This leads to form the salt, that is sodium zincate, and this zincate is that is nothing but the metallic that is anionic oxide of the oxygen, anionic oxide, and it will also forms the hydrogen, and this hydrogen can be also be tested with this one. So not all the metals reacts with the bases. We have some metals, the reactive metals, they react with the bases. So it will be interesting. The next interesting reaction is the reaction of the acids with metal carbonates. What are metal carbonates? Metal carbonates are, that is, this CO3 2 minus is the carbonate. So the metal carbonates also reacts with the metal, and they will give rise to the corresponding salts, and they will release the carbon dioxide and water into the reaction mixture. And this carbon dioxide gas can be tested easily. In earlier classes, you may have tested the carbon dioxide gas by carbon dioxide gas does not favors the burning. So if a burning splinter is near to the carbon dioxide, then it will be burned off. So this carbon dioxide can be tested. Another thing is here in this experiment, when this carbon dioxide gas is passed through the lime water, it returns the lime water milky. So let's see another video, and that will show you, that is the reaction of acids with carbonate. So play this video.
And here I would like to inform our viewers, you can also watch this session on a GeoTV app, and moreover you can watch it on ePathshala app too. And if you have any doubt, then do not forget to call on our toll-free numbers.
So we have taken the sodium carbonate in test tube. Now we'll add drop by drop dilute hydrochloric acid to sodium carbonate, and immediately after the addition of acid, the reaction between the carbonate and acid will start, and it will form the carbon dioxide. When this carbon dioxide gas is passed through the lime water, it turns the lime water milky. See how the carbon dioxide gas is formed. The brisk effervescence of carbon dioxide gas will be formed when acid reacts with the metal carbonates. When this carbon dioxide gas is passed through lime water, it will turn the lime water milky. If you will pass the excess carbon dioxide gas through lime water, then this lime water will again become colorless. This is due to the formation of calcium bicarbonate. So as we have seen that this sodium carbonate, this is sodium carbonate, Na2CO3, this is solid. When we have put the reaction of this sodium carbonate with HCl. So these two are reactants. This is a chemical reactions. In the left hand side, you have the reactants, and in the right hand side, these are the product. So product formed will be the salt, that is the NaCl. It will lead to form the salt, that is sodium chloride, and along with the sodium chloride, it will form the water molecule as well as the CO2.
Okay.
So on passing the carbon dioxide gas through lime water, this lime water was turning milky. Why the lime water was turning milky? Because this lime water is nothing but the calcium hydroxide. This is the calcium hydroxide. Hydroxides are the OH minus ions. So this is the calcium hydroxide. This is the aqueous solution of the calcium hydroxide. So when this CO2 is passed through the lime water, we are getting a white precipitate of calcium carbonate. So this is the test, that is the evolved when the metal carbonates react with the acids, they will give rise to, they will evolve the CO2, and we have tested this CO2 gas by treating it with the lime water. So when this lime water is treated with CO2, it will shows the white precipitate, and this white precipitate is because of the calcium carbonate. Now these metal hydrogen carbonate will show the similar type of reaction. What are the metal hydrogen carbonate? Metal hydrogen carbonate are differ from the carbonate in having one hydrogen. They are the HCO3 minus. So here the sodium hydrogen carbonate, that is NaHCO3, this reacts with the hydrochloric acid. Again, it will form the salt, and along with the salt, it will form the water molecules with the liberation of the CO2. And this CO2 can also be tested by passing it through the lime water. So till now we have studied the reaction of the acids and bases with the metals, metal carbonates and metal hydrogen carbonates. Now let us see how the acids and bases react with each other. When an acid is mixed with a base, both neutralize the effect of each other. This reaction between an acid and a base is known as neutralization. Let us see a demonstration video showing the neutralization reaction. So let's play the video, neutralization reaction video. Video 4. So in our test tube, we have taken the dilute HCl when this acid is mixed with base, that is when NaOH is added to it. Before adding NaOH, we are putting the indicator, that is a drop of phenolphthalein. So we have taken the hydrochloric acid, and along with the hydrochloric acid, we have taken a drop of phenolphthalein. Now this phenolphthalein is not showing the color because phenolphthalein does not show any color with the acid, but it will show the pink color with the base. So add drop by drop sodium hydroxide solution to dilute HCl. So in this demonstration video, you have observed that a point is reached at which the solution becomes pink color. Can you explain why with the addition of base the solutions become pink in color? And this color has disappeared on adding a drop of HCl. So the base gives pink color with phenolphthalein indicators. In the above activity, the acidic nature of HCl is destroyed by the basic nature of NaOH. In other words, the addition of sodium hydroxide neutralizes the acidic character of hydrochloric acid. So let's see the chemical reaction of this neutralization reaction. When this HCl, this is hydrochloric acid, when this is treated with NaOH, so what we have done in this HCl, we have put a drop of phenolphthalein indicator so that when this acid will be neutralized by NaOH, or the NaOH will be accessed to the pink color with the basic solution. So here the HCl reacts with NaOH and it forms the salt, that is NaCl, along with water molecule. Let us see a similar in this particular reaction. This NaOH has neutralized the acidic character of HCl. That's why we have got the pink color of phenolphthalein. When this HCl was again added to the pink solution that is containing the NaOH, again the phenolphthalein was colorless because the solution again becomes acidic. So in this particular reaction, that is the reaction of acid and base is a neutralization reaction. Both acid and base neutralize each other. Right. And if you can come across the general reactions in all the acids, the general reaction is there is a formation of the H2O molecule, and this H2O molecule is formed because the acid gives the H plus ion and the base gives the OH minus ion. So this H plus ion meets with the OH minus ion to form the H2O. That is, the water molecule is formed. So overall, the neutralization reaction is, that is, the reaction of the H plus, that is aqueous H plus ions with aqueous OH minus ion to form the H2O. So this is the neutralization reaction. In general, the acids reacts with, acids are the substances that produces hydrogen ion by reaction with water. For example, when hydrogen chloride is dissolved in water, it reacts with water and produces hydronium ion, that is H3O plus. And similarly, the base, the hydrogen ion cannot exist alone, but they exist after combining with water molecule, and this hydrogen ion must always be shown as either H plus aqueous or hydronium ion, that is H3O plus. The aqueous solution of this hydrogen chloride is known as hydrochloric acid. So this is the hydrochloric acid. Similarly, let us see what happens with the base is dissolved in water. When the base is dissolved in water, this base will give rise to two ions, that is Na plus as well as OH minus, and base gives OH minus, that is hydroxide ions in water. The strength of a given acid or a base depend upon the number of H plus ions or OH minus ions produced by it. And this strength of an acid can be shown on the pH scale. Acid produces more H plus ions are said to be the stronger acid, and the acids that give less H plus ions are said to be the weak acids. This can be shown in form of a scale which is known as pH scale. This pH scale is measure of hydrogen ion concentration in the solution. So this pH scale varies from the number 0 to 14. So if the pH of any solution is 7, that means that solution is neutral. That is, neither the solution is acidic nor it is basic. When it goes downward, that is, if we move from the pH value that is 7 to 0. So here, when we are moving from the 7 to 0, there is increase in the H plus ion concentration. And this increase in the H plus ion, more is the H plus ion, as we have said, acid that produces more H plus ion concentrations are stronger acid. So if you are moving from 7 to 0, that is their acidic strength is increasing. Similarly, if you are moving from the 7 to 14, here the concentration of the OH minus ions is increasing. So from 7 to 14, the OH minus concentration is increasing. So the bases which are producing more OH ions will be more basic in nature. So if we have an acid that's pH is 3, and if we have an acid that's pH is 5, so the stronger acid will be which is having the pH 3. Similarly, if we have any base that have the basic pH of 8 and 10, then pH of 10, the base with 10 is more basic in nature. And this is the pH scale. So we can say that is, if the pH of any solution is 7, then this is the neutral solution. The pH of neutral solution will always be 7. So the water molecule, the pure water, is having the pH 7. The pH value is between 0 to 7 represents the acidic nature of the substances, while those which have pH values from 7 to 14 are the basic. So here, between 0 to 7, it is acidic. Between 7 to 14, it is basic. So let's have a, generally what happens if we want to know the pH of a particular substance, we used to have the pH paper, or there are some universal indicators are there, and that universal indicator show specific color. So depending upon the specific color, you can identify the pH of that particular solution. So let's have a interactive simulation, and in this interactive simulation, we will carry out a particular activity, and in this activity, I will show you the interactive simulation. And this simulation is...
Dr. Anand, unfortunately, the time is up for this session. So maybe you can carry on with the same topic in your next session.
Just give me 2 minutes. I will show. So this is the fat simulation. And in this fat simulation, we have a reservoir. And along with the reservoir, we have, this is the pH paper. You can say it is pH paper. What are the possibilities which I have? I can add the water in this reservoir. I can remove the water or any substance in this one. And I can test to this one. When I'm immersing this one, the pH of the solution is found to be 7. So let's, what are the different substances we have? So we have the different substances. Here we have the different substances like this one. So we have the different substances like drain cleaner, hand soap, blood, spit, water, milk, chicken soup, coffee, orange juice. Let's have the battery acid, what the battery acid will be. So we have taken the battery acid. When I will test the pH of this one, when I will immerse it, here the pH of the solution is 1. So if we'll add some water to this one, here the pH, note down the pH indicator, the pH is continuously increasing. So you can see that why the pH is increasing, because we have diluted the solution of this one. Have you ever imagined you can take the pH, you can identify the pH of the blood? So let's have the blood. And you can take the amount of the blood also. Here I have taken the ½ liter blood. It will be possible to have the ½ liter blood, but I can take it by the use of the ICT. I can take the more amount of the blood also. When I will test to this one, the pH of the blood, it is showing it is 7.4. So these are the interactive simulations. Such interactive simulations are easily available at the FAT and the other ICT resources also. You can use these interactive simulations.
So today we understood what happens when metal reacts with acid or base. We get salt and hydrogen gas. We also understood about the natural and synthetic indicators and about the pH value. And thank you so much, Dr. Anand, for talking to us.
Yeah, thank you, ma'am. And one thing I would like to share it with our viewers, whatever the videos or demonstration videos which I have shown you, they are available at NROER, ePathshala, and Arya Ajmer official YouTube channel. And such type of interactive simulations are easily available at the FET simulations that is a part of the Colorado University.
And in the next session, we will talk about Hindi stories region. So be with us.
Thank you.